So welcome back to my stream. For everyone who's new to this, my name is Patrick. I'm working on the Rescript project, which is, as you know, a JavaScript-like language, which is based on an ML-based system. And I'm working on the documentation platform here, working on the UI, working on the content, trying to make sure that the documentation is structured in a way that's easy for JavaScript developers to understand what this language is about. And I also have been working on this like playground thing. I built it from scratch actually. Back then this used to be a very interesting mix of like different JavaScript bundles on reasonml.github.io back then. So now we unified it and we also upstreamed the whole process on a Rescript compiler repository as well. And cool. Yeah, this is great to read. I mean, there are some features in this. I can actually show you what the playground used to be. And I can explain you a little bit. I can give you a little bit like a guide through on how this whole thing works, because I think it's quite interesting on how this all comes together when you're trying to build something like a playground. So here, this is like the old playground back then. It has like different fields. Here it's the reason code. Down there is the, I think if I hover, if I hover over the other fields, you can see what the others are. So this one is the reason field, this one the OCaml, and this the JavaScript one. And maybe a lot of people don't know this, but you can actually put in content on each side and it will transpile it back and forth. So the problem was there's a lot of things going on here. There's the reason field, of course. And since OCaml was a very important factor in reason, they also exposed this field here. So you have not much real estate here, the JavaScript code here. And also you got the console in the preview. This is something we don't have in a current playground yet. This is solely because this part is actually quite dirty, like in the implementation. For console, like what we need to do is we need to compile the code, right? And so when I'm putting in here some code, you usually get some export code here. And if we do something more complex, for instance, are you going with the evil worker approach for the new playground? Yeah, this is something I'm exploring. But let me explain what's happening for those who are unaware of what problems need to be tackled to make eval work. So let's say I'm using a list module, or maybe belt.array.length. Oh man, okay, so this is like reason syntax. Okay, this is... Oh my god. Okay, we are using reason syntax and the syntax errors in reason are not that good, unfortunately. Okay, so this is a better example here. Here we are actually requiring the standard library, and in there is like this ominous belt array module. And this is problematic if you eval that, because right now what we are doing is we maintain different versions of the Rescript compiler. And if I'm switching to 8.3 or 8.4.2, they all come with their own set of runtime libraries which are compiled to JavaScript. And actually we need to track two kinds of artifacts. The first one is the actual compiler artifacts that are used by the compiler. So you have your belt module exposed as a CMJ, CMT file. And these are like virtualized in the JavaScript runtime with JSFOCaml. And then you also have for your runtime a set of JavaScript files, and you need to bundle them up and load them into your JavaScript runtime environment. And this is kind of tricky because if I'm using like an eval worker or whatever, I need to separately load these standard library files first. And I'm not entirely sure how I should do this when I'm switching compiler. I need to override the original standard library I've been loading. And I'm not sure if there is like a lot of new nuances I need to like I need to figure out if I can create this kind of stateless environment where I can switch to a new version and it cleans all the state and then re-implement this whole thing again. I'm not sure what to do with the spammers in this platform. It's extremely annoying. I think I will just give you like moderator rights, JC, if you don't mind. I'll just give it to you. Feel free to remove that messages if you see them. Okay, so going back to this whole problem, so when I'm switching the compiler version, this is not a problem for this specific version here because you have no toggling of a compiler version. So what this thing does is it just bundles up the whole standard library as one file, and it bundles up the compiler as one file, and it also bundles up the reason syntax as one file. And for us, this is all one monolithic compiler entry point API kind of thing, and I will show you how this looks like in action later on. So let's explore a little bit how this whole thing works. So if I go to common, we have, or actually I need to go back to source. We have bindings and we have the Rescript compiler binding right there. And what this does is, maybe I'll look into, because the Resi syntax is not lighting up right now in GitHub. But what we have here is an external binding that maps to the global namespace. And when we look, here, we have Rescript compiler attached. So we basically, what we do is whenever I switch to a specific compiler version or when I load up the playground, it will take the version number and attach a script to the DOM. So somewhere in here you will find a script which dynamically adds the compiler.js file, and it also adds the dependencies for the compiler, for instance, reason react. This is very important because we also want to be able to use JSX and compile React applications in there, which is a little bit tricky because actually I would like to have like a dedicated switcher for specific reason React or Rescript React versions later on. But you need to make sure that you compile each dependency with the right compiler version and then create the build artifacts for that, which is an infrastructure problem. So we need to solve that on the infrastructure level first. And all this stuff is hosted on our CDN, which is provided by Key CDN. And yeah, we just need to, like, what my code does is it makes sure that it attaches the script tag, and then later on we have our Rescript compiler attached to the global namespace, because this is how JSFOCaml works basically, or at least for our example. And in there we have an API version which tells me how to interact with this specific bundle. So later on, if you decide to change the shape of this Rescript compiler namespace, we would just raise the API version here. And in here, we will find a make function, which creates me a new context for my compiler. And within there, I have different functionality. I have convert syntax, for instance. I can convert let a is 1 from Rescript to reason, for instance. Whoops. Okay, unknown from language. So this should probably go so here you can see if you run convert syntax from reason to from Rescript to reason, let a equals 1, we'll get like a result, and it contains the code from lang to lang and type success. So this is like a tagged union. The type success tells me that this was a successful operation, of course. And if I'm missing something here, it will return me type syntax error. And within there we have errors, and then we can display this here. And the errors are NZ encoded. So this means you will find these weird escape sequences here, which essentially say, like, there is like a table of NZ codes and you can look it up. And for instance, this one means text color red, and the escape 0 means clear up the color context. So this is mostly for color coding. And when I checked it out here, I have problems and whatever in here. And this is using exactly this thing here. So if I do this, it will tell me like syntax errors, and then you get all this stuff. And you can see that we are actually parsing these ANSI codes and color it correctly in our context. And we actually wrote an ANSI parser, like a handwritten parser just for this kind of stuff. I can show you, if you're interested in that, I can show you that as well. And then it's just a matter of printing out like React components, like mapping this ANSI data to the React components, and then it's displayed here. So this is like how the API works. There is also some other stuff, for instance, Rescript. And in here I can see the version. This was actually a very big concern of mine, because here you never had like a perception of what version is currently running. You had this weird issue where you could not use the object syntax here, hashtag, because this is I think this is running on an ancient version of Reason. And it was never clear how to publish a new version there, and I wanted to clean this up. And that's why I actually added this version flag here for each language. So I also have Reason version 3.6.0, and we also have OCaml.version, so we can also see what OCaml version is running on there. And I think, as a matter of fact, if I use convert syntax, maybe. We can even use that to print ML syntax. It's probably not the best example. So what is ML? Let add. Maybe like this. And then we get ML syntax out of it. So we could theoretically also implement our like syntax toggle to other syntaxes as well. Just as a side note, we kept Reason syntax here because actually we didn't want to include it, but we know that a lot of our users are still relying on the old Reason syntax, so we kept it. And it's merely for like playing. It's not to be meant as like production ready conversion, because there is always a loss in certain extent. It's very hard to simulate because I don't have an example at hand, but there are situations where Reason or Rescript are adding certain annotations to their code, and which is only used by the respective syntax parser, and this one is not interpreted in the other parser, and then you have like a lot of, I don't know, like annotations in there, like ns.string or something, which don't make any sense, and the user should not actually see that. That's why we kept this like syntax conversion to a minimum, because it doesn't make any sense for us. We want everyone to write Rescript syntax at some point, and we don't want to polish that printing part. We just want to get people going. Just they have one snippet, they want to look at the Rescript syntax roughly. Defining in, yeah, that's a good one. It will translate, but it will look ugly. So if I define a infix operator, and then we use it, actually plus was a bad idea. Let's call it different. So if you do this and then we convert it, then it will convert it to like the workaround syntax of Rescript. Yeah, I mean, there are some features in Reason that are not supported. Another one is function syntax. So if we convert that, it will, yeah, you can see it's loss. There is a loss in there because it doesn't translate back to the straight example. Now, when you switch to Rescript syntax, it will expand it to a switch. And when you switch back to Reason syntax, it will stay a switch because the information is lost. Anyways, that's why we didn't include it. And another factor why we don't add OCaml here is because it doesn't have any format functionality. And this is a big deal because if you look at the code right down there, I mean, it will print it in some way. And here you can also see the like the annotations I was talking about. Here is a Reason raw literal, and we kind of need to clean it up, which is a lot of work. And if you have a little bit more complex code, especially GSX and stuff like this, it would just get out of hand and will look really, really weird. And we don't have any pretty printing facilities for OCaml. So for us, it is important that the whole thing looks very polished. And if there's no proper pretty printing, we don't want it to be visible for the end user who is like getting started with Rescript. It's just a matter of like, this is just how our brand works right now. And at some point we wanted to have like an independent page where you can have all the syntaxes, maybe some syntax switching tool, which is solely for OCaml developers. Then it's not really a problem. But for this specific case, yeah, we didn't want to do that. Good. So now we know that we have this compiler namespace, right? And if we go back to our binding, which is basically attaching to this global namespace, so we have a lot of bs.vol in there. So right there we have the compiler. We bind to the Rescript compiler called with the make function. So to create a new instance, and then it's basically the same thing. So it's just a typed layer on top of what I've been showing you here in the in this, how do you call it, in the console. So here we will find a convert syntax function, for instance, and here we even added like convenience labeled arguments so people know what these parameters are about. And what we also do is we use the BSJSON library to decode our stuff. As I said before, we have tagged unions in there. So maybe you can see it on the top here. So if the type is syntax error, for instance, we need to branch out and parse it differently. So we do this here as well. Here we have like different entities like compile fail, which say it's either a syntax error, type check error, warning flag error, other error. And this is classified with the JSON we get in. So we get a blob of JSON like this one in our function. And then we check the first field type, if it's like a string. If it's a string, we check what kind of field it is. And if there is anything like we don't expect, it's like some kind of error, and we need to show it separately as some exceptional error. This is usually something the user should never see, but it's still good that we catch it and handle it. Yes, so we have this binding layer, so this is hopefully quite stable. This is like the low-level APIs we want to use in our playground. And then we also have something more like a layer on top, which is the compiler manager hook, which is dedicated for, which is used for React-based development. How it looks like is it's like a state machine. It keeps a certain state. For instance, it's currently initializing, or if there is a setup failed, for instance, it didn't load the the compiler bundle, or it couldn't load up the recent React dependency or whatever. And then we define a set of actions we can dispatch, like switch the compiler, switch language, format, compile code, update config, stuff like this. In the beginning, I thought it would be good to have this kind of reducer-like pattern and dispatching actions and stuff like this. But on the other hand, I realized that it might be a problem for our current setup. And today I want to explore a little bit like alternative ways on how to do this, because what I actually want is, if I press something in here, like when I want to separately format something, then it's like an imperative call, format my code. The rest of the UI should probably not depend on it too much. But in the way it is designed right now, I need to always reconcile the whole state, because I'm dispatching an action. The action has a certain state, and then I cannot really do a lot of fine-grained stuff, which I usually could do if I had an imperative API. So to have a look at the implementation of this compiler hook, for instance, so we have all the information about the CDN, where to find the library version. For instance, the compiler version or whatever library I'm looking for. If we go, how does standardly build recent React, etc. being bundled for the browser? Right now, it's not bundled. That's my current problem. But I wanted to figure out if this is even needed. Maybe we can actually get away with ES6 importing, because usually what I expect is that users are on the bleeding edge browser. Otherwise, it doesn't make much sense to like interact with our website. So maybe we get away with just, maybe I can show you how this looks like. CDN, Rescript like. So in here we have, for instance, 842, and we have the standard lib in there. So all this stuff is in there already. Maybe we can get away just by loading all this stuff. Although it would probably be better to have one bundle, because less I/O. It's usually easier or less expensive to load, to do one request instead of doing 100 requests. There's also Reason React in there. These are compiled with Rescript. So all the stuff you see in here is compiled with Rescript. And except the compiler.js bundle, which is compiled with JS/OCaml. Actually, in fact, the Rescript compiler itself cannot be compiled with Rescript to JavaScript, because there are some dependencies which cannot be transpiled to JavaScript with Rescript. But it can be transpiled with JS/OCaml. For instance, the compiler lib stuff with the AST traversion and all this like low-level stuff you usually don't use in Rescript. This is available in JS/OCaml, so you can compile this one compiler.js file. It's also not desirable to be able to compile the compiler with Rescript, because it's a lot of work to make everything like compilable, and in the end, JS/OCaml is better for the job. Okay, to get back to the stuff. So when we go into our hook, where is it? Use compiler manager. We have an initial language and we have an on action. And the on action is quite nifty, because I can show you. So whenever I'm hitting like a key, it's actually compiling. So every keystroke is actually causing a compile. And this is pretty crazy, because the compiler is so fast that I don't block the main thread, which is why I got away with not using a worker, because the compiler is just so insanely fast, even in JavaScript. And here you can see that this thing is always blinking, right? So when I type something, it's blinking. And this is kind of the UX I wanted, because sometimes, like, imagine I'm changing this. Like this. I don't even know if it has compiled, right? And with this visual cue, I know exactly that something happened, right? So for me, it was important to get some visual feedback. And for this, we use the on action handler. So whenever a state transition happened, we actually call the on action. So whenever I dispatch, I call the on action. And this is also something, I'm not sure. It feels more complicated to define everything like declaratively, for the gain of, I don't know, like you have way less flexibility and it's a lot more code. Okay, so when we start this whole thing, we create some state and start with the init. So the whole state machine, if you want to call it like that, creates the new value, puts it in the state, and he also has a set state, so we can switch to another state later on. And then it creates, actually we are essentially doing use reducer, but I'm using set state to be more flexible, because I don't like to be restricted by this. So we create our dispatch ourselves, and based on the action, if it's like switch to compiler, we get out the context and do a state transition. If it's like switch to compiler, we get the ID and the libraries. We switch on the state again, check if it's ready. There's like a ready state. So it doesn't make any sense to start a compilation when we're currently switching compiler, right? And it doesn't make any sense to compile something if there is already compiling. So we're just doing like this huge pattern match on, depending if we're doing something already, either we do something or we actually do nothing. So when I'm compiling and I want to compile, then we're still like do nothing. And for format, this is, I don't know, kind of tricky. Because as I said, sometimes I just want to be able to trigger a format without like doing a whole dispatch thing. And also like keeping track of the problems and warnings at the same time is a little bit cumbersome here, because I need to go the route with the state. I need to do this indirection of dispatching something and then get the state. And when the state actually, I will show you later when we look at the playground how it's built right now. Okay, so just imagine that you get back two values. You get a state and you get a dispatch. That's all we need to know. And this hook is also very useful for anyone who wants to implement their own like little Rescript playground and they want to use their own facilities, because they just copy this one file and they copy the bindings for the API, and then they can just use it, drop it into any like React application, because the playground is fetched from the CDN, so it's not even dependent on any installation of like the bundles or whatever. It's just globally fetching it, and the CDN is open for all course related web like URLs, so everything is enabled, which makes it a very, very useful tool for anyone who wants to host their own docs or whatever. I still didn't document it too much though, because I'm not sure if the API will change. Okay, to go to the components, we don't have it here, but we have everything what we need in the playground.res, which is a huge file of around 1,600 lines. And on the very bottom, you will find the root component, of course, and which is let make. There are a lot of let makes, of course. Okay, no, it's let default. So it starts here, and we receive like the initial content and stuff, but later on we do use compiler manager. We get the initial lang and pass in the on action, and we have like for on action, for instance, we set some random value and cycle it through. And for compiler state and compiler dispatch, we keep these two values around to do all our other stuff. And now comes the tricky part. We need to use our editor, and our editor is built on CodeMirror. And CodeMirror is very imperative. Like you need to create a editor instance, and then you need to call like instance functions or methods on this editor instance, so you can change certain things around. And this doesn't mix really, really well with React, because React is more about declaring your UI and defining some props, and based on the props render UI. It doesn't really fit into this philosophy, so I need to work around it. For instance, when we want to do some syntax conversion and reformatting, so we can take the success results and set the editor to the new formatted code. which is, I'm not sure what I'm doing here. Compiler dispatch. So we format it, right? We run a dispatch to format, and later on it goes back here if it's ready. This is actually in the use effect. It should actually be in the use effect. But the idea is to, okay, we formatted the code, and then after it's back to ready, we need to compile it again. Otherwise the code might be out of date. And this is like a weird cycle which is not intuitive to understand. We're also using a use effect here. Mostly about running a timer. So when a certain timer has been hit of 200, 300 milliseconds, it will run the compiler dispatch and compiles the code. It's basically like, and when it's already set, we don't trigger it. And here we are also extracting all the errors for code mirror. So this is another interesting part. So we map on a compiler state, we pattern match there. It must be ready, of course, and then because if it's already compiling, there are no errors, right? And then we have some kind of final result if it's a compilation, like compilation result or a conversion result when you convert from one syntax to another. This is also like possible. For instance, I convert from here to here and I made some mistake. Then it will say the code is not valid Rescript syntax. And vice versa. So there is this kind of case as well. And then we have some kind of warning errors as well. So there are different kinds of warning errors. There's a warning flag error, which is more, I think more related to these flags, what we can set here. Right there. And then there are like, this is just like, we don't hit this case that often, more like little warning error where whenever we are doing something funky like this, we get a warning there. And then we get this warning error as well. And these code mirror errors also need to reflect on the sidebar right there, which is the gutter. So we need these code mirror errors here to be able to show like these exclamation marks. And we also need to trigger that imperatively again. Yeah. So I created a code mirror component which receives all the errors all the time. And I should probably open the code mirror on the next thing. By the way, I haven't been looking at the playground for quite a while now. So for me, this is more like I'm reflecting on this whole architecture, so I get a idea of what we have been doing so far, and get back to this because I wanted to start this kind of from anew and maybe try it a little bit more like simpler. Maybe we can make it a little bit simpler just by using the code mirror thing, maybe make it a little bit more straightforward and use like imperative handles to easily like trigger certain things and expose this. Like I don't like that right now I designed it in a way where, let's go to the component itself. It gets a huge list of declarative props. So you have like style, class name, max height, min height, whatever. And we create a ref in there for our code mirror instance, so it doesn't re-render whenever we are doing something in here. So this thing actually never re-renders, like never re-renders the whole component. It's more like it creates one ref which points to our code mirror instance. It is mapped once to the DOM right here, and here it sets the text area. It initializes the code mirror stuff, which replaces this text area with the code mirror DOM thing. And from there on, we are manipulating this code mirror with imperative API calls. Are there any issues which would be a good first task to get into the playground code base? Yes, there are a few. My favorite issue I have right now, and this is probably one of the best to understand the architecture or learn about it. I'm not sure what I need to do, but let me see. It oftentimes happens when I copy a blob of code. Do I have some blob of code? Yeah. So whenever I copy some blob of code, it somehow, I'm not entirely sure why, but oh, maybe because, okay, so these markers, I told you about it. So these markers are getting inserted as CM errors right here. So these are like an array of code mirror errors created in our playground. And we need to manage the gutter. And the gutter has gutter markers. And before we actually draw the new gutter, we need to clear it. So when we look at the errors, oh, wrong file, sorry. If this is getting confusing, just let me know. So we have this update errors thing here, and it clears all the markers, and then later on, or clears the gutter, and then later on it redraws them. So it gets access to the wrapper, and then it appends the child. So this is completely, that's why I say this is like pure imperative. Like you need to manage all the DOM nodes yourself, which is unfortunate. But on the other hand, it's also making things easier. Anyways, when you already had like a gutter error and you paste a blob of code, there might be a situation where the gutter is not cleared correctly, and then there is a marker pointing to a line of code which doesn't exist. So it puts it on down here. And this is something I actually thought I fixed, but for some reason it still prevails. I didn't create an issue for that yet, but if you're interested to have a look at that, I can create it. But this is like the most prominent one. And then there are also some other issues which I'm not sure how to tackle it, because you need infrastructure like the eval console thing, how to do this. But this needs a little bit more thought on how the architecture should work. And yeah, and there's a lot of tricky code in here, but I'm trying my best documenting it. For instance, since we are heavily relying on this imperative code, we need a lot of use effect. So whenever certain things in my props, like whenever a prop changes, we need to do certain things. So for instance, here, use effect 0 means I think you just have, so the reported CM gutter issue should have been warning state before some blob of code pasted in the playground. Is this correct? I think it doesn't matter. You can have any, like at least a marker. There should be, I think, not even sure if it's, you probably need like an existing error first. Let's see if it's reproducible. So let's see, we throw in, we do nothing. Let's say like this. Okay, this works, but if we produce an error first, or maybe like a warning, and then paste it in, this also seemed to work. Okay. Then maybe let's produce an error. And let's do the whole thing again. Also seems to work. So I'm not entirely sure, but there is, like if we play around with it and just blob in some random code, at some point it will yield an error. And then you will see it on the bottom. It appears to happen randomly. I'm not entirely sure why this is. Or it actually, or maybe it has something to do with on which line it is. So now it seems to work. This also seems to work. Maybe if it's like on the last line or something. Nah, I don't know. Sometimes it happens, sometimes it doesn't. That's the worst kind of bug we can have. Yeah, but anyways. So what I did here to mitigate this problem, because I kind of fixed it before, like it was, previously it was way worse. It happened all the time. What I did was I created some kind of errors fingerprint, which receives all the errors and concatenates them together to a row and column. So it knows exactly what error has been on which row and which column. And then we use it to determine if we should like update the markers. So when the errors that come in from the props are creating the same fingerprint, then we will just update the, like if they're different than the render before, we will just run our code mirror operation and update the errors. And this CM operation is just code mirror's way of dispatching their own like imperative calls. So it can queue them up and preventing like race conditions and stuff. Yeah, and then there's like some arbitrary stuff, like if class name or window width or something changes, we also need to run code mirror refresh. So for instance, when you load code mirror once, it's not a problem. It knows the boundaries of its DOM. And since it's using like absolute positioning and fixed width and height. It always needs some like information that it needs to refresh whenever you resize the window. So when I'm resizing, I'm using a hook to like to debounce on the resizing event, and whenever the resize event hits a certain threshold, like I leave it be for 200 milliseconds, it will trigger code mirror refresh, and then you will see that, whoops. We have our text area in here, and we also have our code mirror here. And then we have, yeah, here you can see it, that top position and all that stuff. Not sure if you can see if it's actually updating. Top. Yeah, it's kind of finicky how this whole code mirror thing works. You need to understand how editors or rich text editing and etc. works. Here it's like separating each line into its own little div, and it also has the gutter, which is, I think, here. So you have the gutter errors and you got the line numbers, which is also a gutter. So it manages a whole lot of DOM elements that are mounted to this one text area instance. And when you mount it to a text area, it also automatically hides it. Like the original element is being hidden, and then you see the actual code mirror instance. I think code mirror itself is pretty lean, so it's quite well encapsulated, and the design is also quite sane. It's also relatively easy to understand. But when you want to use it with React, it can kind of be finicky. That's why I needed to create this like whole lot of code here. Actually, the code itself is not that big because most of the stuff here is just the API for code mirror. So these are all external bindings, most of them probably zero cost. And then I also had, like, I created some domain types like mark text option, text marker, and some DOM utils to create, like, to set all these different events on mouse over and stuff like this. I'm actually not sure why I need set on mouse over. Oh yeah, I originally had some functionality where, and this is also something I wanted to have again, because previously, like this would also be a nice feature to work on. For instance, if I'm doing this, I would also be I would like to be able to hover over this and see the text message of this thing here. And previously I solved it differently before, because previously this pane was down here, but it took a lot of space, and when you hovered over it, it highlighted up this area. So I created some really cool highlighting feature. But I think, like, UX wise, yeah, this would be a feature I would be willing to like merge if someone would try to implement it. I can give some pointers on how this works, but essentially, I mean, we are already there, right? So we have a set on mouse over, and we have our errors, and we would need to provide this element right there. The thing is, how should it look like, and how to do the pop hover. This is like a lot of DOM manipulation. So you would be most likely using the DOM API because you know the text marker position, most likely. Sorry. So you would know the text marker position with the code mirror API. And you would need to attach the DOM node on the hover. And then when you leave it, you should also remove it. Like, this is the most annoying part, like always keeping track of things, which React actually is really good at. But in Code Mirror, we don't have that. I'm currently trying to set up my camera because I see that my camera is back. Just give me 1 sec. At some point I should get a proper camera, I guess. Yeah, doesn't matter. I think for this session it's fine to go without. Yeah, but anyways, we would probably need to inject these errors into our component as well. Yeah, maybe we can try this today. Oh yeah, sure. If you find time during the weekend, have fun trying it out. I mean, it's not too hard to get started. What you would do is you would check out the project, go with the README, and run your local dev. Go to the playground. Sometimes you need to refresh a second time because the layout is fucked. But you refresh, you get the page, and then you can just go to the playground file and go to the default export and check out how this whole thing is implemented. And then you can just try it out, and it should fast refresh actually. So when you change some code, you don't have to refresh. It will just pick it up and automatically re-render, which is really nice. Like, the dev experience in Next with this kind of setup is really, really good. Okay, so this is how this whole thing works. And what I want to do today is I would like to create some kind of like snippets thingy where we have something like this. So we have some kind of box, and then we can maybe switch the compiler version on the fly and maybe have some, you know, like your typical snippet playground mini thing like widget, and maybe make it configurable to say what kind of features should be visible. And yeah, something very simple. And we will probably re-implement the whole thing because I would like to explore some other directions on how to design this, just to be sure to have the right design, because like the playground itself is fine how it is right now. There's no point in like completely rewriting it, but if we find a new design which is actually better with the imperative handle and stuff, then maybe it would make sense to also migrate the new playground to the new API. That's my strategy, and I did this a few times already with other parts of the website. For instance, the sidebar architecture, how this whole sidebar is being generated. Used to have 2 different versions, and I was playing around with different implementations, and later on it was super easy to just refactor that. So don't be afraid to have multiple implementations of the same thing. to explore new ideas, and if something goes wrong, you can still scratch the new idea and go with the old approach. But this is unrelated to Rescript itself. Just saying that it was very easy with Rescript to later on refactor that. So the first thing we want to do is we want to go to, so first we run our dev server with yarn dev. This will run the Next.js development server, and on another tab we run yarn run bs start. It's still called bs, but I will rename it to res at some point. We're also using already the new Rescript React package and Rescript Promise. So if you want to use these, feel free to do so. So it's compiled successfully, so we should be able to go to the local host 3000. And we will use the landing page as our playground for now. And the landing page should be on pages, index MDX. And right now there is nothing. So I assume that it will be in source. Like in source is all our Rescript code. And in here we have our layouts. And within the layouts we should have the landing page layout. Right there. There is a subtle button, a call to action button. These are like these two buttons here. And the make to make this all happen. This is like the whole layout then. So what we want to do here is we will just create a code snippet component or playground widget for now. Note how I'm not creating a separate file for now because I don't see a point in doing this yet. Okay, so we have a div. Just to make sure that this works, we put in a hello. And we insert it after our subtle button. So we have children right there. We can put it in here. And we didn't do any refresh. And now we should see our component right there. And now we should probably define some props. For instance, we could define some code here, which could be empty for now. And we could define, yeah, let's just go with code. And we can actually, yeah, let's go with code. Let a is 1. And now what we want to do is we want to go up to our playground. And we would like to introduce, actually we just want to have the code mirror stuff in there. So we have our code mirror component. And for now, I will just copy paste as much as possible. And see what happens. So errors, we don't have any errors yet. So we will leave this empty. We have an onChange function. So that's an interesting one. If we go here, we have an onChange function. And we use code mirrors onChange to register a new function onChange, of course. and we get our code mirror instance and run on value change with the value of code mirror. So whenever I'm typing something, I need to update my state with the new code. And the editor code here is actually stored in my compiler state. Or is it? No, it's not. So it's here, it's a ref. And the initial content would be code. Initial code. This is also quite useful if you want to implement the reset button, then you can just use the prop again to reinitialize your editor. So that's actually straightforward. And we have this typing timer thing, which is, yeah, I made a comment there. The code mirror state and the compiler state are not dependent on each other. So we need to sync a time@compiler function with our compiler state to be able to do compilation on code changes. The typing timer is a debounce mechanism to prevent compilation during editing and will be manipulated by the code mirror on change function. Right, so we will just insert that in there as well. Man, I was really thorough with my comments there. So time@compile current. So the time@compile is usually like some kind of function, and we set it to something when compiler state is ready. Otherwise, okay. So we can leave this out for now. We can just say that compiler, the time@compile is just an empty function. Like in this case, it will never really do anything. And on marker focus, this is relevant for you because you wanted to work on, hey Yuzu. So you wanted to work on this hover thing. The on marker focus was like my attempt. Like I in my playground, I used the set focused row call to independently, I made a comment there, the user can focus on error and warning, which is stored in a ref and triggered by the, so what I wanted to do here is actually, and this is what I did before. So I have this independent state, right? Focused row call and focused, and set focused row call. And within my code mirror instance, I was able to implement some kind of event on marker focus, and then I could like just call the set focused row call, set some row call, and then within my React app I could declaratively show like the highlighted row call. I used an underscore to prevent the unused values. This is an unused value right now, but before I hooked it up with my highlighting logic. And I wanted to do it that way because I wanted to spare myself the extra effort of keeping track of this DOM element. So maybe what would be a good idea actually. So if I go to the playground, right? What we could do, I'm loading this in localhost. So if I have some error right there and I want to hover over that, it would call set, how is it called? Set focused row call. So I hover over that, it calls set focused row call, sets the state, and the state triggers a re-render of a pop-up, for instance. And then we can independently keep track like maybe in a ref, you have like one like absolute positioned div in there, which is hidden. And whenever you hover over something, we can use React to use effect and get the current cursor position and just render our React stuff in this like hidden field and then show it on the position. Like then we set top and left position to the cursor position, and then you will see the pop-up here really nicely. And you're still like, and then when you hover over that, you change the state again, set focused row call to none, and then when it's none, you hide this panel again. That would be a very interesting approach showing that, because then you can actually use the whole same logic you find here. You create a pop-up element, the hidden pop-up element, which renders the same logic as my problems field here. So you can use the unzip parser and all this stuff. There's also like an unzip, I think, unzip pre component. And in the unzip pre, you can check out the logic here. So you basically just copy paste that stuff, what's used here, use it in the pop-up. You set the state for this, and then whenever the state changes, use effect to listen to the state change, and then you show the pop-up right there. That would be really neat. Now that I know React so much better, I could actually implement it right now, but I think it's really cool. It's a really cool opportunity for you to learn this. So if you find time this weekend, I will not implement it anyways now, but if you find time, feel free to try it. Nobody has been working on the playground so far, so you will be good to not collide with anyone else. Okay. And actually these tasks are actually super interesting to me, because Rescript is a really, really good language for building React applications, in my opinion. Like these, as you can imagine, like this whole playground component is terribly complicated or complex. There's a lot of state transitions, a lot of actions dispatched, a lot of synchronous, like how do you call it? Syncing problems between the compiler state and the user interface, and it's really, really tricky to express that in even in TypeScript. It's hard to express in TypeScript because you need to like intersect tagged unions. Just the fact that we have variants is such a powerful feature. I would actually say that variants are the only reason why Rescript is better than TypeScript. I mean, of course, the type system and such, but like from a, like if I'm just concerned about UI development, variants are the #1 factor why Rescript is nice to work in, or the combination of pattern matching, switch as an expression, expressing complex domains in like this really neat type syntax. Okay, so playground widget code, the function is oh yeah. So now we have a mismatch here, because this is called initial code. Yeah, other than that, I mean, TypeScript has all the features, but in TypeScript, this is like my #1 complaint. If you're writing TypeScript, let's imagine we define some state. And let's imagine we have a button which, or whatever, we would need to create like an object which has initial, hover, active, and when it's active you have some selected, which is a string, maybe kind of an ID or selected ID maybe. Yeah, I would actually, like, I wouldn't mind if TypeScript would added to the language, but I think there are many, many, many issues and also overlapping features that will not make it happen. Like maybe we get some pattern matching syntax or something. That would be great. But like this concept is, I mean, you probably have seen this many, many times. It is fine how it is, kinda. Like this is like the best you can do probably. But when you do like this terrible switches and then you need to, like, you have the state and then you have type and it's all type checked and everything, whatever, but it's just so brittle because now you need to do like a scope here, otherwise it will hoist it to the upper scope, and then you need to like selected ID is now state.selected ID, so you need to extract it here. If you have like deep values, which are a little bit more complex, it's getting out of hand very easily. Then you have like this weird like default syntax, like all this stuff. And the worst thing of all, whenever you want to know, like, I don't know, like is active or whatever, you need to create a let is active, and then you need to is active equals true, whatever. So this is such a weird pattern, and I just don't know any like level, like without going back to some kind of weird object syntax and then have callbacks to express that thing. Like there is no syntax native solution on doing the same thing with Rescript, which is this let is active switch, and then you have like its initial whatever, then is active is false, and actually it would be like, it's super tedious. Like I've been working on some client projects and I do this now-ish and I'm super unhappy with it. Like this pattern is just terrible, and if you're using that and you think it's fine, then you have not tried variants. Variants are the single best feature for UI development, that's my opinion. Because you need this all the time. Like you just need, like, you have a text field and you want it to be accessible. You need 5 different states to make it like proper. And when you're dealing with like plain objects and then do intersection checks with ifs and switches, no, this is not cutting it. It's making the code very unreadable and very error prone in my opinion. And also the error messages are out of this world if you have some complex state. Okay, sorry about my quick rant about TypeScript, because TypeScript is so mediocre and so, I don't know, worse is best, I guess. Like, it could have been a nice language, but the add-on features just to grow the language and grow the community, and everyone loves it, but I wish there would be a simpler approach to this whole thing. And this is what Rescript is. Rescript is very simple in comparison. It doesn't implement a lot of features. It gets to the point. It's very easy to understand if you don't go wild with the types and stuff. Anyways, we're back to our code mirror. It compiles. And if we go back to our landing page, we get an internal server error. And this is very important. Why do we get this? This is more like a Next.js specific problem. Next.js is an hybrid framework which compiles to client-side JavaScript, and it also compiles server-side rendered HTML pages. So whenever we are using code that cannot be rendered on the server, it will crash the server. Right? Because there are certain browser APIs that the server doesn't have in Node, and we will probably have some weird error here. Navigator is not defined, for instance. So CodeMirror is heavily client-based. It needs to run in a browser. It cannot be run in Node.js, so we need to make sure to not run this code specifically in in Node. And so what we need to do is we need to lazy load it. We need to tell Next, don't render this on the server. And what we can do here is we can look at how we solved it in here. So if you can remember, if you go to the playground, it's the try page. And the try page is including the playground. And in here, we're using this thing here, dynamic. This is like a feature of Next.js they provided from their Next package. It's a function which receives a callback to import some stuff. And it will create a new React component out of that. And then you can provide some flags for like SSR is false, for instance. So for this specific thing, we can tell Next.js, okay, we import our playground and we want this playground to only render on the client side. We can also add some property like loading, which means it will render an intermediate component telling you that it's loading. And then it will basically work for client and for server, right? We also have our next res, because this is like JavaScript right now, but we also want to do this in Rescript. So we go to our next.rez file, and here we have dynamic. So we have bindings for that in the dynamic submodule. And in there we have our dynamic function, which does the same thing. So it receives a callback with unit and then some promise t with a result. We don't necessarily care about the result. And some options. And we also have this import here to map to import in general. I'm just not sure why I typed it as A, because this doesn't make much sense. It should actually be some React component, but probably because I need to cast it myself. It depends on what the import is actually returning you. I think the Next API says that we will check it up on the Next.js docs. I usually try to stay as close to the original implementation, of course. So if you look up for dynamic, we have dynamic import and supports dynamic import for JavaScript. With it, you can import JavaScript modules dynamically and work with them. You also work with SSR. In the following example, we implement fuzzy searching using Vue.js. Funny, they also use Vue.js. Basic usage. Okay. So we get dynamic component, dynamically loaded by the page, will be default component, works like props, normally would. Yeah, so this is kind of, yeah, you can also modify it if you want. Like import is like a browser API which which returns you a promise that contains the module. And if you have like an ES6 module, you will have access to module.default and module.whatever it exports. So if you decide to import like a nested module or whatever, you can import it and then chain it and then return the subcomponent, for instance. Now my problem here is that this is highly unsafe because we return a promise with type A, and type A should actually be some kind of module, and in here it should be like I cannot verify it because it's coming from the outside world. Anyways, what we need to do is we do one thing. We go to our layout. Maybe it's still okay. I changed my mind. I will take the playground widget and create a new file. And this is super easy in Rescript because I just go to source components playground widget.res. I paste this and then I remove that code here. I save, then I save this here and it should work, right? Because every module in your code base is automatically global. So landing page layout.res is now accessible from our landing page layout the same way as it was with a submodule. This is a great feature in my opinion. So what we're gonna do here now is we're gonna make some state here. And what we can do is we can say it's init or loaded maybe. And state, set state, react.useState, and we return init in the beginning. And we will use code mirror element, which will be it's a dynamic component, right? So we need to it's a component, right? So this is tricky. This is tricky. So we do this thing right there. Class name, min height, mode, arrows, value on change. Anyways, we use next dynamic and use dynamic, which receives a callback. And in here, we'll use next dynamic dot import and then we need to see what's the actual output here. And then we use the make export to actually so we need to go into source components, code mirror.js. So we get that. And then we need to promise then this. And we get a module. We get our module, and within there we need to transform it to something else, which would be mod make. So we would return this. The value input is required but not provided. Oh yeah, extra easy, and we also need to change it here. I use an underscore afterwards because I think this name escaping is kind of weird. What about your promise proposal? I didn't have time to read the forum the last week. Anything new happened? Not yet. More flat map discussions, but other than that, nothing much. I made my final statement about that I care more about... Oh, this is wrong. Should be map. So it's make A. I made my statement about that I care more about understandability, in meaning that we are closer to the JavaScript semantics, or JavaScript naming, because it would usually be then. Some people argue that it should be flat map. I prefer 10. Anyways, I think we will not get to a proper conclusion there. So now we have this code mirror element, and this is a React component which receives some props there. And these props are based on the code mirror code here. So we have errors with min height, we have max height and all this stuff. This is a very exceptional case on handling this code, because code mirror is not compatible with server-side rendering. And I have no space on my editor, which makes it a little bit harder to scope. Anyways, we have some props in there, basically. And what we will do here is, when this whole thing is rendered, we will set state. But I'm not sure if this is even possible. I think this is probably not a good idea. I'm not sure. Can you run set state in a dynamic? Is this possible? Let me think this through. I will just try it. Let's see what happens. So now we have our code element, and it's actually code mirror component. And code mirror element would be react.create element, code mirror component, and a list of props. And this would be essentially this, like this stuff right there. Just wondering how we can do this. So we create our element. I mean, I wish there was maybe with the new GSX, with the new React component transform, we will be able to make this a little bit cleaner, because right now what our problem is, the code mirror component should actually be written like this: code mirror component, which would allow us to use GSX to express that thing. Now, that we don't have that, we need to use create element as an API and then pass the props as like as a JavaScript object, which makes it a little bit less nice to look at. So it would be like this: props, and we go until here, put it in there. On change. Oh no. Okay, so now we probably get some error right there. So we wanted next dynamic options. All right. So we go back to our next Tracy, and we have options there. And these options we should also provide. And this is done in our dynamic. Right here. Next.dynamic.options. SSR is false, and then a last unit for doing nothing. Okay, so now this is at least compiling, but we will check out the playground widget JavaScript file here to see what happens in the background. So we would run. Okay, this looks interesting. Dynamic return import from next dynamic. Yeah, so we run dynamic, and then we run set state. We provide options false here. Wow, this is super ugly. And then we have the props. But this is, I think, not correct. So I want to provide, in a function, known the browser after user types in search module. I would like to know how I provide props. Because this is now a code mirror component. Alternatively, it will... Okay, no, I think this should work, actually. Okay. Okay, it took a while to get there, but seems to work out. Yeah, it's inefficient. But that's something we wanted to solve at some point. Dynamic imports are a little bit more tricky because we need to know what kind of code we're importing. And later on, we also need a way to do the props passing more efficiently. And there's some proposal where we can actually provide the... I can show you in the forum. Where is it? So that was the idea, to provide React component, and then we can actually provide the props separately. And also the PPX will allow... Oh wait, let me see. Oh, actually I could use this. This is actually better. Make props. That's an idea. So we would do code mirror dot make props. Yeah, we need to do it that way. Yeah, and the problem is that we can't... that we currently can't point to the props right there. So this should be something like code mirror dot props or whatever. But this value doesn't exist. So this is kind of tricky to get like a typed boundary somewhere. But props would potentially be code mirror dot make props. That would probably be a more sane way to do it. Class name. Yeah, now I need to convert this whole thing yet again. At least now it's kind of safe, so to say. But this is, yeah, I mean, the problem is that in dynamic imports, we don't know what kind of export is coming out of this. So this is kind of unsafe. And yeah, it's just something we have to deal with. I guess it's not possible to know if all the arguments have been applied on the JavaScript side because it accepts variable number of arguments. I'm not sure what you're talking about here. But I forgot that I need to actually provide a last unit. So now this will create me my JavaScript object here. This is just a very dirty part of it, but yeah, it's just something we need to deal with. I'm just wondering because I would like to have some way to show that this is actually currently loading. Because this will now basically, I mean, it pops up now, but if you load it from scratch, it will always like pop in the UI, and I don't want that. Anyways, so we don't want this to be like this big. But we need a min height and we need a max height. Okay, so now it has a certain height. Probably not a good idea to show the DOM while you're editing here, but you can see now that this is like a certain size. That's important. And we should probably be setting it to 1 height. Yeah, did you see that? It was popping. This is not good. So it'll be interesting to see if my state is actually recognized here. Yeah, that's what I thought. So the set state is not being triggered. So the question is, what I actually want to do is yeah, I want to start out of init. So while it's init, what I want to do here is I would like to use class name, meta string, children. I would like to use markdown code, and or do I want to actually use markdown code? Make code element, code example. Code example uses code and lang. So actually want a code example. Code example is probably a bad name. Code equals res. No. Code equals initial code. And lang equals res. So while it's in it, I want to show it like this. Kind of. Kind of not. I also don't want to have this other stuff. Like I don't want to show the label. Show label. Oh. Show label equals false. Okay, so now we have this code snippet here. And I also want to wrap it in anyways, just to get the point across what I try to do. So I essentially want to have some kind of button here. Or what I can also do is I can use the while this is loading thing. But then it's still it's a terrible UX question. So while this thing is loading with custom loading component. Let's try it and see what happens. So if I'm using this, on the other hand, when I want to switch when I want to be able to switch some stuff, I still need some toolbar of some sorts. Okay, we have the edit. And when I press the edit button, I want to load this thing. Yeah, this is terrible. So when I'll click this. But this is like, this is just a major flaw in how dynamic import work in Next, because it doesn't give me any way to get control of the loading procedure. It's kind of weird, because like, how do I prevent popping UI if I have no chance on reacting on certain events? Like, it is managing the life cycle within this dynamic component, and I can just use this component and it will like trigger the like show the loading component while it's loading. But I have no real control on what happens after it has been loaded. Or at least I don't see any cue on how to do this. So it will only, so I press edit, it will, okay, I have edit, I press edit and then it should show the, yeah, it should, wow, this is so hacky. So we have loading and loading. By the way, I'm not having troubles with Rescript per se. I'm more having trouble with how do I get the nice UX out of it, because seriously, there is no visual cue on how to do this. Okay, reload this whole thing. Press edit, loading compiler, and then it loads it. And I don't like this at all, because it's like kind of resizing. Do I need these values? I don't need these. So if I apply the height onto this feller, So this should always be it should actually always be expanded to the full size of this. I think I'm reaching my boundaries with my code example component here because I have no control. I have no control on the inner padding on this. I have control over this value here, so this is fine. And the edit button should not be there if I'm already in edit mode. Yeah, the best way to probably solve this UX issue is by being able to actually server-side render the code how it looks like in Code Mirror, and then when you load the page, it will automatically load the component, no matter if it's being used or not, and you will always see like the same snapshot. And later on, when it's like interactive, it will seamlessly replace that component without the user noticing. And it would have the same height and width, and then it would look all nice. Yeah, I think I'm gonna stop here because it's already 8 p.m. I think we got a lot of like theoretic parts done, and I hope you understand what's going on in the playground now. I will push the progress. It's to my feature branch now, and then let's run it back to what we did today. Source bindings, source layouts, and source components. Okay, so it's there on the playground widget branch. To summarize what has been going on, so yeah, I hope it's informative. So, but hopefully it's not too complex, right? I mean, it's like you have the compiler binding, as I showed you before, in source bindings, which is the low level API for accessing like this globally scoped compiler API. You need to use in common, you will find the compiler manager hook, which does all the logic for attaching the script tag to your DOM in the right order. So you can easily like get access to this globally accessible compiler API. and the rest of the logic is all located in one file. So there's not much going on here. It's in source, playground res. You basically start from the very, very bottom. This is like the entry point for everything. And from there on, you just climb the tree down until you reach the component you're interested in. And I made sure to add a lot of comments in there, so hopefully it will be straightforward. I mean, it's maybe be a little bit daunting that there is like 1,600 lines of code. But since everything is basically a component, hopefully you will find your way through. Okay, so that's it for today. In case you have any questions, JC, if you're working on this on the weekend or whatever, feel free to ping me, either on the forum, or you can also write me on Discord. And for everyone else, thanks for joining. And I will usually do it every week, so maybe next week I will continue this work. Wednesday, 6 p.m. CET as always. And yeah, I hope you liked it. See you next time, and thanks everyone for watching. Bye bye.